So, good morning guys. We are the group 3 and we're going to discuss about network security infrastructure. So, the learning outcomes. So, by the end of the chapter, the student should be able to compare firewalls and intrusion detection prevention system and make recommendation for deployment to monitor and control network traffic. Second is design network segmentation and virtualization strategies to create separate security zones and control lateral movement. So, the third learning outcomes is evaluate the use of deception technology like honeypots and honeynets to detect malicious activity and gather threat intelligence. The fourth is develop requirements for a security information and event management solution to aggregate, correlate, and analyze log data to identify security incidents. Last is need to manually prepare data using a Linux command line. So, introduction, a brief introduction about network infrastructure. This is a security designed to monitor hardware and software to protect the network infrastructure against malicious attack, to enforce access control rules, and to ensure that only authorized users are able to use network resources, to detect and remove malware, and to provide secure channels such as virtual private network or VPN for remote users. So there are 4 topics here. So let's first discuss the topic 1, which is the firewall and intrusion detection prevention system. So a firewall is a network security device that prevent unauthorized access to a network. A firewall can be physical hardware, digital software, software as a service, or SaaS, or a virtual private cloud. So firewall basically secure the perimeter of a corporate network. So firewall filters the traffic, block unauthorized inbound and outbound traffic. So the firewall can be a network or house base. So network firewalls are arranged on the gateway computers routing traffic from a workstation to an external network such as those within local and wide area networks or intranet. So the difference of the network or host base is in network-based firewall, it examines the data packets, headers, and block addresses or ports, while in host-based firewall, its function is act as an independent safeguard. So you can see in the diagram, this is the figure 1, and the firewall here serve as your first line of defense. They scrutinize inward or outbound traffic for any malicious contents as per your rules. So, enforce the principle of least privilege. The same concepts apply when deploying firewalls. Applying the principle of least privilege reduces the firewall's attack surface. So, deny all incoming and outgoing traffic by default first, then build up your rules by enabling only the services whose traffic you want in and out. Disable services or software that aren't needed and limit the applications that run on the firewall. So how do you strengthen your firewall rules? So periodically sprinkling your firewall's policies to maximize its performance and eliminates conflicting rules. But more importantly, it lets you audit your firewall's architecture and streamline if it needed. The SANS Institute has a checklist of rule sets that can serve your benchmark. Ensure that your firewalls enables anti-spoofing filters as users and management permissions rules. For example, allowing HTTP to a public web server or simple network management protocol traps to network management servers. Make your firewall more efficient by running noise rules, dropping unwanted traffics, rules that notify IT system administration of suspicious traffic and recommendations, lag the traffic for analysis, back these log up, and store them in secure repositories. The next to firewall is intrusion detection system. So intrusion detection system, or IDS, is a device or software applications that monitors a network for a malicious activity or policy violations. So the difference between intrusion detection prevention system to firewall is IDS can identify malicious attacks such as malware and distributed denial of services attack, and then alert the security team. Network-based IDS recommendations. So a network-based IDS should be deployed on the external demilitarized zone, or DMZ segment. Then the DMZ segment, this will allow monitoring of all external and DMZ malicious activity. So a network-based IDS should be deployed on the external demilitarized zone segment. Then this will ensure all devices connected to an external hostile network are monitored and checked.
Deployment of network-based IDS. A network-based IDS should be deployed first as an industry and recommended standard. Host-based IDS recommendations. Host-based IDS should be deployed as a secondary task in a three-tier approach after a network-based IDS. Deployment of host-based IDS. Host-based IDS deployment should be after network-based as an industry standard. Firewalls and intrusion detection system, or IDS. Define and secure the perimeter of a corporate network. Firewall filter traffic, blocking unauthorized inbound and outbound traffic. Firewalls and intrusion detection system are both cybersecurity solutions that can be deployed to protect an endpoint or network. Firewall acts as a barrier controlling traffic flow, and IDS actively monitors for suspicious behavior within the network. Together, they provide layered security to protect against different types of threats.
Network segmentation is when different parts of a computer network or network zones are separated by devices like firewalls, switches, and routers. Network segmentation is a discipline and a framework that can be applied in the data center and on premises at an organization's facilities. David Landsberger, 2023. Network segmentation is the practice of breaking a corporate network up into multiple pieces based on systems' role and trust levels. Implementing network segmentation helps to prevent lateral movement by an attacker within the network if they attempt to pass through these network boundaries. Is a network security technique that divides a network into smaller distinct subnetworks that enable network teams to compartmentalize the subnetworks and deliver unique security controls and services to each subnetwork. Network segmentation, the process of dividing a computer into small parts, improve network performance and security and manageability. It helps in access to sensitive data, security, breaches, and optimize network traffic flow. Community segmentation is the process of dividing an actual community, separate logical subnetwork. Following the separation of the community in a smaller additional potential units are applied to different compartmentalized segments. How does network segmentation work? Network segmentation creates isolated segment in network, each with being security requirements and policies using perimeter-based VLANs and network virtualization techniques. For deeper segmentation, it works by creating a logical boundaries and network using firewall, router, switches, or virtual LANs. These boundaries restrict communication between different segments based on predetermined rules and policies. By segmenting network, organizations can control the flow of traffic, isolated potential security threats, and limit the impact of breaches and malicious activities. Perimeter-based segmentation creates internal and external segments based on trust. What's internal to the network segment is trusted and anything external is not. So, based on the level of trust, perimeter-based segmentation is divided into internal and external segments. So, the internal segments are considered trusted, meaning the resources within these segments are assumed to be safe and authorized, while the external segments are considered untrusted, meaning they could be dangerous for security and more strictly regulated and observed. This approach helps organizations manage and protect their network sources by limiting access to trusted entities and forcing security measures for external entities trying to access the network.
Good day, I am Rochelle A. Alejandre and I will discuss the network virtualization. Network virtualization combines hardware and software network resources into a single software-based network or transform a physical network into separate virtual ones. So, the network virtualization merge both the physical components like cables and routers with software elements to form a unified network that operates mainly through software. It can either blend all these resources together into one large virtual network or divide a physical network into smaller, independent virtual networks. So, this approach simplifies network management and allows for greater flexibility in allocating and managing resources. Network virtualization also boosts security by letting organizations divide their networks, keeping trusted and untrusted parts separate. So let's proceed for the benefits of network virtualizations for organization. First is the faster provisioning and time to market. So the faster provisioning and time to market means using software to create virtual versions of network equipment like switches and routers instead of physical ones. This makes it much quicker to set up networks because you don't have to wait for physical hardware. So you can get projects and services to users faster. Improve efficiency with automation. So this one will allow IT professionals to automate various network tasks such as configuring network settings, adjusting resource allocation, and balancing network loads. So this automation speeds these processes, making the network more efficient and agile. So instead of manually doing these tasks, the software takes care of them automatically. Strengthen security. So, strengthen security enhances security by isolating virtual networks within physical infrastructure, preventing unauthorized access, and securing communications between resources with enforced policies. And the last one is the greater policy consistency and adherence. So, greater policy consistency and adherence keep rules consistent for tasks by linking them to a virtual layer. When tasks move, rules move too, making change easier. New tasks automatically follow the rules, keeping everything the same across the network. So, let's proceed for the strategies for robust network security. First is the network segmentation. Network segmentation means splitting the network into different parts based on things like who's using it, what applications are being used, or how sensitive the data is. This helps to reduce the chance of security problems by keeping any issues in one part of the network from affecting the whole thing. It also means only letting people into the parts of the network they really need to be in. Access control. So, access control is about controlling who can use different part of the network and what they can do. It uses a system where people's access is based on their job and who they are. This helps organizations reduce the risk for unauthorized people getting into sensitive areas by only giving access to those who really need it for their work. Intrusion detection and prevention systems. So, intrusion detection and prevention system or IPs are likely digital security guards for your computer network. They keep an eye on all data flowing through the network and look for any signs of trouble, like unusual patterns or behaviors. If they spot something suspicious, they can either raise an alarm or automatically block the threat to keep your network safe from attacks. And the last one is the network monitoring and auditing. So, network monitoring and auditing means regularly checking your network to find any issues or rule violations. By keeping an eye on how data moves and regularly reviewing everything, organizations can catch any strange activity or problems early. Network monitoring and auditing helps keep the network safe and make sure it follows the rule.
Hi, I'm Janet Taganas and I'm here to discuss about the honeypots and honeynets. How is a honeypot different from a honeynet? A honeypot is a single service or computer on a network that is configured to act as a decoy, attracting and trapping would-be attacker, meaning it is like a digital trap set up to deceive and catch a cyber attackers. It's typically a computer system or a network resource that appears to be part of a legitimate network, but it is actually isolated and monitored. A honeynet, on the other hand, is a network of honeypots that are used to lure in attackers and study their activities across multiple honeypots. It takes the concept of a honeypot to the next level by deploying multiple honeypots across a network, creating a more extensive and sophisticated trap for attackers. These interconnected honeypots work together to simulate a larger network environment, increasing the chances of attracting attackers and capturing their activities. What is a honeynet? Honeynets are a great way to study the behavior of hackers or attackers, and the primary goal of a honeynet is to provide a more comprehensive view of an attacker's behavior and techniques by observing their interactions with various systems and services within the network. And this image illustrates the honeypots and the honeynets. And what is a honeypot? Honeypot cybersecurity or decoys are lures made to replicate the behavior of a real system or service on a network to draw cybercriminals away from a legitimate target. They act as traps, enticing cybercriminals to interact with them instead of targeting the actual production systems or a sensitive data. These decoys are intentionally made to appear as a legitimate and valuable targets to attackers. Like what I said a while ago, it's typically a computer system or a network resource that appears to be part of a legitimate network but is actually isolated and it is monitored. Honeypots can be classified into two different categories. The first one is the production honeypots. Production honeypots are deployed by organizations, private companies, and high-profile individuals to gather threat intelligence on attackers in production systems. These honeypots are configured to mimic genuine systems or services to entice attackers and gather threat intelligence directly from real-world attacks. The second one is the research honeypots. Research honeypots are designed to collect data and information on the methods used by the attackers. They collect data and information on the methods utilized by the attackers in a controlled and monitored environment and are typically isolated systems specifically set up for studying cyber attacks.
Continuation. Type of honeypots. Service honeypots. These honeypots are low, medium, or high interaction honeypots that represent a service such as SSH, FTP, RDP, web application, API, PLC, RTU, and etc. So, dito sa service honeypot is madami siyang nire-represent na services. Dito naman tayo sa example types. May apat na example types dito. First, malware honeypots. Second, spider honeypot. Third, spam honeypot. Last, decoy database. So, proceed na tayo dito sa next, honey nets. Honey nets can consist of one or more type of decoy, such as the combination of spam honeypot and pure honeypot, both residing on the internal network, monitoring for interaction. So, di sabi daw dito sa honey nets is, nagko-consist daw siya ng isa or madami pang type of decoy, such sa combination ng spam honeypot and pure honeypot. Operating system honeypots. Operating system similarity to service honeypot may be low, medium or high interaction, and aim but representing a real computer. So dito daw is meron daw silang similarity dun sa service ng honeypots na kahit mababa, sakto lang or mataas yung interaction, pero represent pa din siya ng real computer system. So, dito naman tayo sa benefit and risk of using honeypots. So, meron siyang benefit and risk. Unahin natin itong benefits. First is expose vulnerabilities. Second, expose lateral movements. Identify insider threat. High alert fidelity. Collect threat intelligence. Turning the table on attackers, incident expose processes. This is the risk. Ito ay dalawa lamang, lateral movements and maintenance and administration.
I'm Angelica G. De La Cruz, and I'm here to discuss the Security Information and Event Management, or known as SIEM. Security Information and Event Management, or known as SIEM. Systems have been widely deployed as a powerful tool to prevent, detect, and react against cyber attacks. This organization has ability to monitor, analyze, and manage security events in real time. SIEM systems aggregate and correlate from various to identify suspicious patterns or activities that could indicate a cyber attack. SIEM software is frequently used to manage data inputs and offer reporting and alerts. They also aid in compliance reporting and incident responses, making them as an essential component of any comprehensive cyber attacks strategy. Log collection is a gathering and storing event logs generated by various system devices and application. Log collection data inputs from various sources must be gathered as the first step for SIEM. There are three different categories of log collection exist. These are the three different categories of log collection. Number one is agent-based. With this approach, you must install an agent service on each host. As events occur on the host, logging data is filtered, aggregated, and normalized at the host, and then sent to the SIEM server for analysis and storage. Agent-based in the context of log collection refers to a method where software agents are deployed on individual systems or devices to collect and transmit log data to centralized log management or SIEM system. Number 2. Listener or collector. Rather than installing an agent, hosts can configure to push updates to the SIEM server using a protocol such as syslogs or SNMP. A process runs on the management server to parse and normalize each log or monitor sources. This method involves setting up listener or collectors on the SIEM server to receive, parse, and normally log data from various sources within the IT environment. Using protocols like syslogs or SNMP is a common approach for log collection without deploying agents on individual systems. Number 3. Sensor as well as log data. The SIEM might collect packet captures and traffic flow data from sniffers. Sensor refers to a device or software components that collects specific types of data or metrics from the network systems or application for the purpose of security monitoring, threat detection, or performance analysis. Log aggregation is the process of transforming data from various sources into a consistent, searchable format. Log aggregation involves collecting and organizing data logs from different sources like servers, application, or devices into a unified format. This process makes it easier to analyze and search through logs for troubleshooting, monitoring, and other purposes. Analysis and report review. A SIEM is utilized from reporting where inputs are produced through collection and aggregation. Correlation is a crucial component of SIEM and the main characteristic setting it apart from conventional log management. SEMI or Security Information and Event Management systems are essential for security reporting and monitoring. They combine log collection, aggregation, and analysis to provide a comprehensive view of an organization's security postures.
Hi everyone, I'm Gemalia Mamuri and I'm here to discuss the continuation of topic 4, which is Security Information and Event Management. Analysis and Report Review. User and Entity Behavior Analytics. The identification of harmful actions is made by possible comparison to a baseline in a user and entity behavior analytics solution. What is User and Entity Behavior Analytics? It is a cybersecurity solution that uses algorithms and machine learning to detect anomalies in the behavior of not only user in a corporate network but also the routers, servers, and endpoints in the network. Sentiment analysis is typically used to track brand incidents on social media, such as a dissatisfied client complaining on Twitter about the service they recently experienced. What is sentiment analysis? It's the process of analyzing digital text to determine if the emotional tone of the message is positive, negative, and neutral. File manipulation. The cat command, viewing the content of one or more files impossible with the Linux command cat. The logger command. The logger command publishes input to either the local system log or remote syslog server.
Hear them haters talk, but there's nothing you can tell them. Just made a million, got another million on my schedule. No love for 'em, nigga breaking hearts. No keys, push to start.